So this is an arithmetic progression that says AP in the title there. And in this instance, we don't have the first term and we don't have the difference. All we know is that the 10th and 11th term are 27.5 and 30. And we want to work out what the 20th term of that progression is. If you want to, Simon, if you want to write it down as we go along, you're welcome to. You can do it in your workbook, so you can just scribble it down if you want to, or you can just take it in the glory that is this example. It's up to you. But I will get you to do your own example in a moment. So effectively, what we need is the ability to work out the information that we don't know. That's where we're headed with this. So we know the general term requires the first term as well as the difference for an arithmetic progression. So we need to ferret that information out from what we've been given in the problem. Or do we? Let's have a look at it. So the first thing I'm going to do is I'm going to write down the problem just using our the language that we explored last lesson. And that is the 10th term is 27.5. So I'm going to go T10 is equal to 27.5 and T11 is equal to 30. Now, in this instance, I can see that I am able to work out the difference because we know that the common difference, the value of D, is worked out by looking at what we need to jump from one term to the next, or effectively by subtracting two terms that are next to each other. So I can then say, therefore, D is equal to, now I'm going to write this out formally, but I wouldn't expect to do it quite as formally as this, T11 minus T10. So I wouldn't do that line myself in when I was solving a problem, but I'm doing it here just for completeness sake, which is equal to 30 take away 27.5, which is equal to 2.5. So that's good, I hope. We've now got a value for D. What we need to do is keep an eye on the prize. It says, what's the 20th term? Now, there are two ways we can work out the 20th term. If we know the general term, then we can simply substitute 20 for n and solve. Or we can use a little bit of logic and say, well, how many jumps have I got from, say, the 10th term to get to the 20th term? So if I just have a look, if you have a look at slide 2 here, and you say, well, I'm starting off at the 10th term, then the 11th, so that's the 10th, then the 11th term will be T10 plus D. The 12th term will be T10 plus 2D, because it's an extra D on. The 13th term will be T10 plus 3D, etc. So rather than starting from T1, let's just use the information we've got, i.e. that T10 is a known value, 27.5, and I need to get to the 20th term. So the 20th term is 10 terms on, right? 20 take away 10 is equal to 10. So we can therefore say, and T20 is equal to T10 plus 10 lots of D. I'm just going down from slide 2 to slide 3 now, with slide 2 being just a little bit of scribble space. And T10 is equal to, so T20 is equal to T10 plus 10D. Well, this is good because this is an equation with three variables there, two of which I know. T10 is 27.5, D is 2.5, and so I can calculate an answer. 27.5 plus 25, and so we have 52.5 for the value of T20, i.e. the 20th term is 52.5. What do you reckon? Okay, so if I don't have the first few numbers of the sequence, then I can use the information I do have in order to work it out. Now, that's good enough for what we've done there. But what happens instead if the question was, what's the general term? Or if it was said, can you please tell me what the 20th, 50th, 90th, 731st, and 1000th term of the sequence is? Now, you don't want to necessarily just keep on thinking, well, how many jumps are there between each of those 5 different problems you've been asked? So in that instance, it would be more efficient to work out the general term and then substitute the positions of the terms that you're looking for. So what I'm saying is that if it's just a once-off, do that. But if you know you have to use it lots of times, or you're asked for the general term, then do what I'm about to do next. Sure. So we need the general term. We know the general form of an arithmetic progression. I'm just doing it in slide 2 there. The general form of an arithmetic progression is that the nth term is the first term plus 1 less than n multiplied by d. I've got d. That's all right. N I don't have to work out because that's the point of the general term. So it's T1 that I need to work out. So if I can do something to work out T1, I can work out the general term. Does that make sense so far? Okay, well, let's use the information we've got. So I'm going to slide 4. And so this is like the bonus, let's work out the general term. Also, no, I won't say given. Also, I think I'll use T11 this time. Also, I could have used T10 for what I'm about to do, but I'm going to use T11 for reasons that might become obvious in a second. T11 is equal to the first term plus 10 lots of D. 10 comes from the 11 minus 1. Okay. Again, this is just using the general form of the equation. So T11 equals T1 plus 10D. Now, the good news about that is, yet again, this is an equation with some stuff I know most of. I know what T11 is. We're told it. I know what D is because I calculate it. So if I substitute those values in, I'm good to go. So T11 is 30. T1 I don't know. But D, we worked out, is 2.5. Now, if I simplify that, I've got T1 plus 25 is equal to 30. And now if I subtract 25 from both sides, and I'll just flip those sides around as well, we get T1 equaling 5. That's good. We've worked out the first term. We worked out the difference before. With the first term and the difference, we can now calculate the general term. So therefore, the general term is the first term, 5, plus n minus 1 times the difference, which is 2.5. And just to be nice and tidy, and I just want to leave it on this slide, so I'm just going to squish it up to the side here. I'm going up that way. So therefore, Tn is equal to 5 plus 2.5n minus 2.5. So Tn is equal to 5 minus 2.5 is 2.5 plus 2.5n. And there's the general term. Hooray. Okay, all from knowing the 10th and the 11th term. Jamie.
Is the general term 5 times n minus 1?
5 plus. Just the general form itself, which is T1 plus n minus 1d. That's all I did. So we've got Tn equals 5 plus n minus 1 times 2.5. Alex.
Can't you use the original method that you showed us, even if there are multiple numbers, but instead of popping from each number after you calculate it, you just replace your T1 with a variable that you already know, and then deduct the amount of variables that is from the beginning when it comes to calculating?
Yep, that would certainly work. Yep.
Why does it say 5 times n minus 1?
Okay, so that says T1 is equal to 5. Are you talking about here? Here? Yeah, so that's a plus sign. Yeah. Sorry if that's unclear. How's that? Cool. Thanks, Jamie. Anything else? Okay, yeah, no, Alex, it's certainly true that there's more than one way to skin this cat, for sure. Okay, what I'm going to do is I'm going to provide you with an example of your own, which I just seem to have lost a piece of paper for me where I wrote the example down, but I'm going to just do that for you. And I'm just going to give you a chance to try and work on that particular problem, and then we'll go from there. So I'm just going to pause the video. Or not. It's having a technology fail day today, I'm afraid. Hopefully this is recording. So here's the same logic applied to a geometric progression. Remember that geometric progressions grow or shrink really, really quickly. So, you know, in a sort of test situation or in the classroom, we're going to pick numbers that are relatively small, just so that we can deal with them easily. They don't get in the way of our understanding. But we're told that the fifth and sixth term of a GP, 8.1 and 24.3 respectively. I should have written the word respectively there so we know that they link up. What is the 11th term? Okay, so same deal. We need to work out, in this case, instead of a common difference, we need to work out a ratio. And once we've worked out the ratio, we can then use that ratio to work out the 11th term. Okay, here we go. So we know that the ratio, I'll spell it out a little bit again. So the solution is, the ratio is when we divide one term by the term before it. So that means dividing 24.3 by 8.1. That's just a calculator operation, or you can do it in your head by moving the decimal place one and just working it out. So that gets you, carry the 1, subtract 17, multiply by your shoe size, and add your house number, and you get 3. Okay? So the answer is 3. 24.3 divided by 8.1 is 3. So that's what R is. Now, using a similar logic as we did before, we can move from one of those terms we do know, in this case I'll use the 6th term, to get to the 11th term. So have a look at slide 6 there. And what I'm saying is that if we start with the 6th term, then the 7th term, then the 7th term is going to be, oh my gosh, the 6th term times R. And the 8th term is going to be the 6th term times R, otherwise known as R squared. The 9th term is going to be T6 times R times R times R. So it's R cubed, etc. Until we get to the 11th term, I'm just missing one term, that's stupid, but T6 times R to the power of 5, okay? How do we work out this number here? Well, it's going to be 11 minus 6. So 11, take away 6 will give me the power here. It's going to be the number of times I'm multiplying R by to get to the 11th term. In general, I hope you can sort of see that if I add those two numbers together, I should get the term number I'm looking for. Okay, so let's write that down. So I'm going down to slide 7 here. Therefore, T11, which is actually T6 times R to the power of 5, is equal to T6, which was 224.3, times 3 to the power of 5. And that's equal to something. I thought you were reaching for a calculator, but you weren't. Let's flick over 24.3 times by 3 to the power of 5. Just doing this on my calculator. And I get 5,904.6. Just calculator operations. What do you think? Is that okay? So again, we work out a bit of the information so we can then work out the thing we're looking for. But let's do the same thing as we did before. Question? I was at 0.9. Yep. What's wrong with me, hey? Owen just said in the most politest possible way, you idiot, Richard. 5,904.9. It actually says 0.9 on my calculator. I'm not too sure what kind of dyslexia means. I read sixes as nines and nines as sixes. But at least it's not as bad as my wife, who when she sees 8 thinks red. Anyone else have that? It's called synesthesia. Like when she sees particular numbers, she sees colors instead, or she thinks colors instead. It's so weird. Red plus red. 2 red equals 16. Yep. Okay. So the general term. It didn't ask for it in the question, which I wrote, but nevertheless, let's do it. So remember, working out the general term gives us access to calculate any possible number in the sequence. And we also get to answer questions like, well, what's the first number that the value will go over 1 million? You know, so we can do stuff like that. So the general term, and let's deal with T5 because it's smaller. And we know that T5 is equal to the first term times by R to the power of 4. That's just the general form of a geometric progression. Tn equals T1 times R to the power of n minus 1. So T5 equals T1 times R to the power of 4. Good news. We know what T5 is already. It's 8.1. We don't know what T1 is, but that's okay because we're trying to work it out. And we know that R is 3 to the power of 4. Okay? Now, 3 to the power of 4 is 3 3s are 9, and 3 3s are 9, and 9 9s are 81. So 3 to the power of 4 is 81. So that's what T1 equals. And 8.1 divided by 81 is what? N is the position of the term. So 8.1 divided by 81 equals 0.1. Like so. Now that we have the first term and the ratio, we can now work out, I'll just go up that way, we can now work out the general term. Therefore, the general term Tn is equal to 0.1, the first term, times R, 3 to the power of n minus 1. Now, like I said to you before, whilst it's possible to simplify that even further, we just don't bother. It's probably not worth the mental calculations in order to simplify it. That's good enough is what I'm saying. So that's it. That's the general term of a geometric progression given two terms that are next to each other, but we still don't know what the first term is. All right, I'm going to pause the video again and give you another one to try. And then we'll come back and look at something different again. So sorry about the crazy pace, but remember this is being recorded. Hopefully it's still working. And as a result, you will be able to go back over these notes a little bit more slowly if I'm going too fast for you right now. Okay, so next problem. So far, it's been pretty straightforward because at the end of the day, the terms have been next to each other. But what happens if they are not next to each other? So let's have a look at this problem. I'm talking slower as I'm trying to work out what I did with my pen. Did I leave my pen with somebody? My actual stylus pen? Yeah, thank you. Okay. So let's have this problem here. The 10th term. So in an AP, the 10th term is 24. And the 15th term, I think I've got that right. Yep, is 44. What's the general term? Okay, so because of time constraints, I'm just going to get stuck into it rather than giving you... Oh, actually, the bell's about to go. So we're going to finish on this. So we are running behind, unfortunately. So We can get through this, I think, though. So we're going to use a very similar logic in a sense, and that is we're going to use our knowledge of how the difference continues to accumulate between terms in order to solve this. So if you think about it, T10 being 24 and T15 being 44 has 5 terms between them, okay? So we would have to add D 5 times. So T15 is the 10th term plus 5 lots of D. Okay? So why is that good? Well, again, because it's now an equation where we know 2 of those unknowns. So we can substitute them in. We can say that 44, which is the 15th term, is equal to 24, the 10th term, plus 5 lots of D. This is an equation you should be able to solve. I'm going to subtract 24 from both sides, and I'll get 20 is equal to 5D. And then I'll divide both sides by 5, and I'll get D is equal to 4. So we've now got the common difference. The rest of it is like we've been solving before. Now that we've got a common difference, we can work out the first term. And T10, I suppose, just bear with me because it won't be too long, is equal to T1 plus 9D. T10 is 24 and D is 4. So we've got T1 plus 9 times 4. Okay, well, 9 fours are 36, which means I've got T1 equaling negative 12. So now that I've got my first term and I've got my difference, I can work out my general term. Now, given that the bell is just gone, I'm going to put a pin in it there, and I'm going to pick up with it next lesson. We'll just maybe go through it. Yeah. Okay, thanks very much, everyone. See you next week.